In this lesson, we're looking at the molecular formula of a compound. We've previously studied the empirical formula. Remember that the empirical formula is the lowest ratio of atoms within a compound, and now the molecular formula is the actual number of atoms in the compound. Right? So you can take the empirical formula, which is the lowest ratio, and multiply it by some factor to get to the actual number of atoms within the compound. And there's two types of questions that we generally experience when looking for molecular formulas. One, where they give you the empirical formula and they give you the molar mass of the molecular formula, then find the molecular formula. So that's one type of question, and here's the instructions on how to do that question. The other type of question that they can give you is like they'll give you the percent composition, right? So what percentage of the compound is this type of atom, so on and so forth. And then they give you the molar mass of the molecular formula, and then you have to find the molecular formula. And again, instructions on how to do those types of questions are right there. So without any hesitation, we're going to jump right into it. Example 1. The empirical formula of a compound is CH3O, and the molar mass of the compound is 93.12 grams per mole. Determine the molecular formula. So again, which one of these two questions is that? Well, I'm given an empirical formula, and I'm given the molar mass of the compound. Determine the molecular formula. That's this one right here. Given the empirical formula, determine, and the molar mass, find the molecular formula. So let's look at step number 1 here. It says 1, determine the molar mass of the empirical formula. So I'm going to go ahead and I'm going to do that. So this is my empirical formula right here. Let's find the molar mass. CH3O, well, that's 12.01 grams per mole plus 3 times 1.01 grams per mole plus 16 grams per mole. And the molar mass of the empirical formula is 31.04 grams per mole. All right, so this compound, in its lowest ratio of atoms, so 1 carbon to 3 hydrogen to 1 oxygen, has a molar mass of 31.04 grams per mole. The question gives us the molar mass of the compound, though, which is more than the molar mass of the lowest ratio. So divide the molar mass of the compound by the molar mass of the empirical formula. So that's what I'm going to do here. So the molar mass of the compound of the molecular formula over the molar mass of the empirical formula. So I have the molar mass of the compound of the molecular formula, the actual number of atoms, 93.12 grams per mole. And I have the molar mass of the empirical formula, which is 31.04 grams per mole. As we can see, our units will cancel. And let's just look at what we're doing and understand what we're doing here. The empirical formula with the lowest ratio of atoms is 31 grams per mole. But the molecular formula, as you can see, it's 3 times as heavy, right? Look, we get a factor of 3. So the difference between the mass of the molecular formula and the empirical formula is by a factor of 3. So what does that mean? I'm going to take this formula right here, and I know that my molecular formula is 3 times as heavy, so I'm going to multiply everything by 3, and I end up with C3H9O3, right? And that's my molecular formula. So this represents the actual numbers of atoms within the compound, whereas this was just the lowest ratio. Okay. The next question says, the percent composition of a compound is 40% carbon, 6.67% hydrogen, and 53.30% oxygen. The molar mass of the compound is 180.18 grams. Determine the empirical formula and the molecular formula. Okay. So this is a really common question where they ask you both for the empirical and the molecular, but this is what we're going to do. we are going to find this one first. Even though it comes second in the question, we're going to find this one first and then just reduce to find my empirical formula. So it says, should say multiply. Multiply the percentages of the compound by the molar mass. Okay, so I take 40% of my compound is carbon. So this is step 1. As a decimal, times the molar mass of the compound, 180.18 grams per mole. And what I end up with is 72.13 grams per mole. And that's for carbon, right? So this is carbon. Let's look at hydrogen. Hydrogen only made up 0.667. And so I'll get 12.0 grams per mole of hydrogen. And then oxygen is 53%. And so 96.04 grams per mole of oxygen. So why did I do this? Well, if I know that 40% of my compound is carbon, that means that 40% of this molar mass is coming from carbon. 6.67% of the mass comes from hydrogen, therefore 6.67% of the molar mass has to come from hydrogen. So I can actually determine how many carbons I have and how many hydrogens I have and how many oxygens I have by doing 72.13 grams per mole. And if I have this molar mass of carbon, then that means there were approximately 6 atoms of carbon that provide this molar mass. 12.0 grams Okay, so I've divided by the molar mass of hydrogen. That's 12. And this one right here, 96.04 grams per mole divided by 16 grams per mole is equal to 6. So literally, these right here are the subscripts of the molecular formula. So, therefore, the molecular formula is C6H12O6, and it also asks for the empirical formula, but if I have the molecular formula, that's really easy because I just look at the molecular formula and I reduce it to its lowest ratio, which is 1 to 2 to 1, so CH2O. Okay. Homework is right here. Thanks for watching.